All right, so I wanted to make a few hopefully quick videos to kind of talk about these inference and equivalence rules a little bit more because I think there's a lot of confusion associated with these. So the first thing I want to mention is about the equivalence rules. So with these, you can kind of think of these as saying something is equal to the other piece. So this is, you can kind of think about it as saying P is equal to not P. They're equivalent, so we can always jump between those two. We can always rewrite one as the other. And so there, if we have P implies Q, that would be the same thing as writing not P or Q. These things are equivalent. So we can kind of use them to just rewrite what we have whenever we have these situations going on. Whereas with the inference rules, they work differently because they only work in one direction. Say I told you that x was less than 5. If I tell you that x is less than 5, then you could also say that x is less than 7, because 7 is greater than 5, so if x is less than 5, then x must also be less than 7. But say I told you that x is less than 7, could you then tell me that x is less than 5? No, you couldn't, because what if x is 6? So with these inference rules, it's kind of that type of idea where you start with something, and the thing that we're then making it, the thing that we're allowed to rewrite it as, is actually weaker than what the original statement is. So x is less than 5 would be considered stronger than x is less than 7. Because x is less than 5 wouldn't include something like 5 or 6, but x is less than 7 would. So we're essentially able to rewrite a stronger statement into a weaker statement. And that's what these inference rules are doing. Now, the thing that I think trips a lot of people up is that they look too much at the exact statement of the rule. You don't need the exact variables in the exact correct places. So I can still use an implication rule even if I have a P implies R, or even if I have something much larger like an A and B implies C. This is still an implication. I can still use the implication rule here. So for instance, if I wanted to use the implication rule on this, well, essentially this first entire piece, this A and B, essentially acts as the P in the rule, and the C is going to act like the Q. Maybe I should do that in a different color. The C essentially acts as the Q value. So what this rule tells us to do is it tells us to negate the P value, so this is going to turn into not P. But if P is that whole entire A and B, we just have to negate the entire thing. And then the rule tells us that the implication essentially turns into an or, if you will. That's not exactly what's happening, but. And then we have Q. Well, that just means that whatever that last value was stays the same. So in our case, it was C. So it's less about finding that exact format and the exact variables. You kind of want to look more at the pattern here. Do we have something implies something else? Do we have not something? And as long as it kind of follows the pattern of that rule, it applies. So say I had something like not, let's say A or B and not C. Okay, I have a not outside of something that essentially includes an and in the middle. So we kind of have this first piece and then the not C. So if I look down at my rules, I want to look for something that tells me how to deal with this not and kind of bring it inside the parentheses. And that's going to be down with our De Morgan's laws. Now the one we're actually looking at, since we have an and here, is we want to look at the second one here. So what that's going to tell us to do is it's going to tell us that we can bring that negation inside essentially as long as we negate both pieces. So we have to negate the first piece. Well, that would just be saying just put a not in front of that first piece. De Morgan's law also essentially says that we have to flip the sign that was in the middle. So if we start with an and, we have to end with an or. And then I have to negate not C. Now technically you should write that as not C to begin with. And then in a proof sequence you would use the double negation rule to then rewrite it. So let's actually keep going with this one really quickly. So as I just mentioned, we can rewrite this not C. So let's go ahead and do that first. So let me erase this so that I don't run out of space. So that not C, if I look at my double negation rule, tells me that I can just rewrite that as just C. And now, what if I wanted to go one step further and take care of this not that's outside of this set of parentheses again? Well, again, I'm looking for a rule that tells me how to work with bringing a negation inside, and that has to deal with our De Morgan's laws. Now, we're starting with an or here, so we're actually in this top situation this time. So that tells us that we can rewrite this as bringing the negation inside, so we have to negate both pieces, if you will. So we're going to have not A and not B, but then the sign in the middle flips, so it becomes an and. But then we didn't touch that or C in the back, so that just kind of flows down from what we had already. So you really need to take a step back and not exactly focus on finding these exact letters in the exact order. You just want to look for the pattern. Do you have some not P or Q? Do you have, P implies Q? And that can be anything. It can be dog implies cat. It can be I'm drinking tea implies I'm sleepy, as long as you have an implication or whatever that kind of pattern of that rule is. So that is especially difficult, I think, when it comes to doing the proof sequences that include things like modus tollens or modus ponens. So say we had something like A or B, let's do A or not B implies not C. Now, assuming this was in the scope of a proof sequence, we would need to have some other pieces, but let's see what other pieces we would need to be able to use modus tollens and modus tollens and modus ponens in each case. So say we had this, say this was a given, and say I want to look at what we would need, so need versus what we would get from these modus rules. So if we look at modus ponens first, well, what do I need for modus ponens that I don't already have right here? So I have the implication already. So I know that I have the implication in each piece, so I just want to look for the thing that I need besides the implication. Well, in modus ponens, I would need P. So I'd essentially need the hypothesis of the implication. Well, in our case, that's going to be that A or not B piece. So I would need A or not B to be able to use modus ponens. Well, what would I get from modus ponens? So modus ponens gives me Q. So it essentially gives me the conclusion of the implication. So for modus ponens, we would be able to conclude not C. Whereas what about modus tollens? With modus tollens, we would need not Q. So not the conclusion, not conclusion. So in this case, it would need not C, or otherwise you could be looking for C because those two things are equivalent. And what would we get? Well, modus tollens gets us not P, so the negation of the hypothesis. Well, that would get us not A or not B. And you also want to be slightly careful because you could also realize that it could also look like this, not A and B. And that's because if I use De Morgan's law on that first line, and I bring that negation inside, I negate each piece and flip the sign in the middle. Well, if I have not B, that's equivalent to B. That's why that one turns out to be positive, if you will. So we would need to be slightly careful in a proof sequence because we'd have to be on the lookout for kind of multiple things. Whereas with modus ponens, we kind of only had one choice. But that's where I'm going to stop this particular video. I'm going to go into another video going over some examples of the proof sequences where you just want to list the steps. But this is the idea behind these rules. We're not exactly looking for exactly P implies Q. It just needs to be, something implies something else. We just need the pattern to be there. We don't need it to be exactly one variable. It can be whatever it is, whatever it needs to be.